Okay, this is a update on my 3D printing. Yeah, it did okay. Made made some parts here. This is the cover that's going to go over the gears, or the pulleys, I should say, on the front of the indexer. This is the plate that mounts on the indexer. Now this plate, it can go this way or this way. More than likely it's going to be towards the back, because I'm not going to have enough room with it on the front or towards me. It's going to have to be on the back side. But okay, what's going to happen here is that this is going to mount here. This is going to mount in there, and then the belt, and then this piece is going to go on here. And then I got this little, I don't know what you call it. It's actually a spacer of some sort. And then this piece is going to go on the back. Then this piece is going to go on the front. It's going to look something like that. Remember I was talking about it probably looked like a primary cover on a motorcycle? Well, it kind of does. So let me put you up here and we'll explain a little bit about this. Okay, when I got this, all right, this remember I talked about this gear. It's got this hollow spot inside. So I had to make this ring to fit in there to take up that slack for that being hollow. It's a spacer. That way when on the back side, or this side is going to be towards the spindle, and this side's going to stick out where the thread is, and I don't want to tighten that nut on the front and crush that. Not that I'm going to crush it, because you're not going to put that much force on it, but you don't want it, I won't say weak, but you don't want it to give. You want a nice solid feel, so when you snug up that nut, you know that the plastic is not going to flex and then loosen up because it's flexing. You want a nice solid feel in there. So that was a little ring I made to take up that little gap from this part, because it's hollow in here. If you cut this, it's hollow. So that was that part. Then, like I said, this gets mounted on the indexer itself. Turn the light on, maybe that'll help a little bit. So these were the helicoils I put in there so that when I put the screws in there I got a nice feel. Now the piece that is going to go in there, I showed you this before. The original piece is a block, and I'm still waiting on that magnet encoder, I forget what you call it, the part that reads the magnet, and it was a square block, and I'm going to mount it in that square block, but I haven't received it yet, so I don't know what the size is. So I'm still going with that one I got from DigiKey. Now this was the one I showed you before that I made, and the problem I was having was that I didn't think it was be a problem, but it turned out to be a problem. Is when I put the screws in here, I can't tighten them. I'd have to take an Allen wrench and I'd have to shorten it. So the thing was that I needed to have a notch in here to access that screw, and that was pretty much the only problem I had with it, except that this distance here could have been another 60 thousandths, because when I put the shaft in there, the distance between the magnet and this piece is where the encoder rides the receiver. The gap was near the minimum, so I needed to extend this distance. I could have recessed the magnet further into the part, but seeing how that I didn't have access to these screws, so I thought it'd be easier to make another part. So that's what I did. I made this guy. This got the magnet inside. There's a piece of tape on it because I want to make sure that it's going to work, and then I'll put a little piece of epoxy in there to finalize it, and then I won't have to put that piece of tape on there. So I made this guy and cut this. Now I have access to that screw hole on both sides so I can adjust it. And the other part that I wanted to do was when I put the spring on here with the washer, most of the washer was sitting off of the part. Not that it made a big deal, but you know, the washer, you know, with the screw here, the washer was, this being the inside, this being the outside, the washer was actually tipped. I wanted it even so that there would be even spring pressure on it, but it was actually tipped because the edge of the washer was coming off of the part. So what I did was I put a little hump there to capture the edge of the washer, and I only put 2 on there. You know, here I had 3, but since I cut the sides of this guy, you know, I only needed 2. 2 will work because all that's doing is just holding that, keeping it from rotating, but you want it to where it be able to rotate. But with 2, it should, with the correct spring pressure, you should be able to rotate it, and it won't rotate by itself. You should be able to rotate it manually, but the any vibration or anything would not let it rotate. So, and I added, like I said, I added a little more distance here, so I got a little more room to move this back and forth Well, it can only go this far, because now it's going to hit the back of the plate. But with a little extra distance, I can slide this up so the magnet will be closer on this end, and I still got plenty of shaft for this because I made it just a little bit long. So that's going to mount on there and rotate. So that's one of the upgrades I did. And then on this printing these parts, I modeled this up, and the thing with the 3D printer is that, I would have liked to have made this all one piece, but the thing with the 3D printer is that it can print a flat surface and it can print walls, but it can't print this piece that goes between here because there's nothing for it to print against. It has to be flat. There has to be something to support it. Now they got a thing where you can go in there and you can they got support features and this and that are built in the program that will put something underneath here to support it. But I didn't really I really didn't want to go that route because I thought, well, if I print it in sections, that way if there's something that needs to be modified or changed, I can just print the section over instead of printing the whole thing. Because the thing with the 3D printers is that they do nice work. I mean, they'll print something and it'll be really exact and this and that, but like I said, it can't print something that's not supporting it, like this piece here. So I had to print this in sections, so I made the model and then I sliced it into different sections so I could print it. So this was the bottom. This lays on the table and it prints this up, and then this piece over here is the part that goes on here. So I had to print this as another section, and this is like 100 thousandths thick. And then I had to print this piece. Now see, with this being flat here, you can't print it like that. You have to print it like this, because you can print something that has a angle on it. They say up to 45 degrees. When it's this being the base and this being the upper part, it will support it as it prints out. It supports it. So, but if you print it with this piece on the bottom, when it goes to print this flat area, there's nothing for it to print against, because how this thing works is there's this like nozzle on it, and this plastic comes through here and it's heated, and it lays down a tiny bead of the plastic that it melts, and it just goes back and forth. Just think of it as a hot glue gun with a very fine tip, and that's what it does. Is it moves back and forth, and it lays down this little bead of plastic, and it just adheres to itself because it's It's like almost 200 degrees, and so I had to print that like that. I mean, it's no big deal. Well, you know, you make a model, you set up the thing, and you tell it to go, and you know, an hour later you come back and you got a finished part. You know, you can't get much easier than that. So this was the same deal. I printed this with this side down, and this is the walls that support it up to the top. Now this is a little scruffy because I took a piece of sandpaper and, you know, it was a little rough, so I sanded it, tried to smooth it a little bit, and because what's going to happen is later on I gotta rough these parts, and then I gotta glue them together. So then I'll probably spray them with a little paint. You know, I went down to the hobby shop and got some glue and got some model paint. You know, the paint they use on the little plastic models. And so I'm going to sand this down. Well, first I'm going to put it together and make sure it works. I'm going to do the assembly on it. Maybe I'll put a little piece of tape on here, a little piece of tape on there to hold it together, and put that on there, put a little piece of tape on it, make sure it works, make sure, you know, it's got the right clearances on it. And you know, you don't want to glue it together without giving a little test fit. Then you have to make all the parts over again. So another thing I did was I got my power supplies in. I ordered 2 of these because I'm getting tired of waiting on parts. So now I'm going to order 2 at a time. That way if something happens to one, I got an extra one right there on hand. I don't have to wait. Because I don't know why this stuff is taking forever to come in. But I got my power supply. This is a little 5-volt. Because they recommend with the Nano that you don't have more than 5 volts going to it. And you know, I've been powering it off of the computer with the cord. But you know, when this is on the machine, I can't run a cord to the computer. I have to have a power supply, and I really don't want to use the power supply that I already have powering the full-size Arduino, because now I'm relying on one power supply to run 2 components, and I really don't want to have to splice into that wires to run another wire to run the little Nano, because that's all set up, and I just want to leave it alone because it's working. And that way, if some, you know, if I go through all the trouble of splicing into the wire and getting some juice out of it and powering this thing up, and it doesn't work, then I'm going to have something that's worse than when I started. So I'm going to have a separate power supply for this guy. And that way each system is separate from each other, because if something happened to this system, it might mess up the other system, or vice versa. And this way, if you have to diagnose something, you know, it's a lot easier when they're on completely different systems. So that's about where I am here. And I guess I'm going to go with that parts I got from DigiKey. Oh yeah, let me show you what that looks like. That's this guy here. That's the little chip. That cost me 6 donuts to get that soldered. Well, I got a bargain on that. But I got a groove in there, and it's flush with the end. So when this piece rides on here, it's flush. Then the wires come out, as you can see, and I got little holes in here, so when you're rotating it, you're not interfering with those wires. Everything's going to be towards the back. But yeah, that's the little guy right there. Hard to believe. That thing is this slot is 200 wide, so that's like almost 200 square. Tiny little thing. Yeah, it's 175 by 200. And I don't know what gauge those wires are. They must be around 28. But yeah, that fits into that guy. Of course, the springs are going to hold that in place, and the only time you rotate it is when you're setting the 0, or if you have to do something else. All right, talk at you later.